Okay, welcome fans, welcome viewers, welcome Justin Bieber. I would like to wish you a happy birthday today. We sang to you yesterday, so if you want to watch us sing happy birthday to Justin Bieber, watch the video from yesterday, pre-cal. Okay, so we are going to learn about rotations today. Rotations are just a little bit trickier than translations and reflections, so let's go ahead and start with the example on slide number 5. So we have a pre-image here, pre is before, and what did they say? The pre-image is the green image. Okay, so the pre-image is here, and they moved the green image to the orange image. So what they have done is they've taken the image, and I just have a point here, and they have rotated it 90 degrees clockwise. The other direction is counterclockwise, okay? But 90 degrees, when you rotate 90 degrees, are all the phones away? Okay. The x-axis and the y-axis change locations. Same if you go 90 degrees counterclockwise, or if you do 270. 270 is 3 90s. 1, 2, 3. Okay, so 270 is actually, 270 clockwise is the same as 90 degrees counterclockwise. Are you guys with me? Okay, and 180, the x-axis and the y-axis do not change locations. So they just go, it just goes. X-axis stays in the same place, y-axis stays in the same place. Okay, but any 90s or 270s, the x-axis and the y-axis are going to change, which means the x-coordinates and the y-coordinates are going to change locations. They're going to switch. So here we have our green image, and it's going to the orange image. And then on the next slide, it's asking us to draw the graph on how the points move. So let's go ahead and move to slide, come on mouse, number 6. And take a look here. The green figure has been rotated 90 degrees counterclockwise. So now we're going to the left to create the red figure. Look at the table of values for both figures. So notice this point right here is at 2, 1, 2, 3, 4, 6. 2, 6. Okay, it has been rotated. The 6 and the 2 change location, so they're going to flip. So now notice down here we have a 6, 2, except for the 6 is negative. Why? Well, we need to talk about the signs in each of the quadrants before we can figure that out. The x coordinates and the y coordinates are both positive in the first quadrant. Do you guys remember that? Quadrant, can I draw on this? I'm about to find, no I can't. It's fine, everything's fine. So in quadrant number 1, x is positive and y is positive. Are you with me? Okay, now let's go to quadrant number 2. Quadrant number 2, because it goes in this direction, like a C, right? The coordinate plane. 1, 2. The sign of x is now negative because we're going left, and the y is positive. So in the second quadrant, we have x is negative and y is positive. In the third quadrant, they're both negative. And the fourth quadrant, x is positive and y is negative. Does this sound familiar? When's this? What grade is this from? 5th? Maybe? Give anyone feedback? Anyone? I haven't taught anything lower than 7th grade, so I don't really know. 6th grade? Okay. So the signs are important because the location of wherever these points are going to, they're going to take the signs of whatever quadrant we're in. So this point to 6, the x and the y-axis have changed places. So those numbers are going to switch, and they're going to take the signs of whatever quadrant we're in. In this case, it's quadrant 2, where x is negative and y is positive. That's why this point is negative 6, 2. Let's do an example on slide, I believe it's 15. Let's move to 15. Yes, perfect. Now this is asking us to do a translation as well, but let's focus on the rotation. So we were asked to rotate the figure 90 degrees counterclockwise. So counterclockwise is going the opposite direction of the clock. So this green figure is the pre-image, and we're going to be drawing the image, and it's going to end up orange over here in the second quadrant. Everybody with me? The signs of those values, the x is all the x coordinates are going to be negative and all the y values are going to be positive because we know it's going to end up in the second quadrant. So now all we have to do is take these numbers and switch places and make all the x's negative. Let's do it. So first I'm just going to switch them. So all I've done is just switch the location of the x and the y values. Now I have to look at the signs. The x's are going to be negative. The y's are already positive. So let me change those x values to be negative values, and they should be good. Booyah! Questions? So if we had to move this figure to quadrant 4, we would do the exact same steps. Switch the x and the y. However, now those values would be in the 4th quadrant, and x would be positive and y would be negative. Okay, you just take the signs of whatever quadrant you're in. Let's go ahead now and do the second step, because on occasion, especially SOL tests, you have multiple transformations that are done in the same problem. Are you guys trying to see behind me? So here we've got a rotation, and now we're going to have a translation. So we have to move this orange figure to the left 1 and down 3. How are we going to do that? That was from the first unit, or the first lesson. Translation. All these, we have to do something to these coordinates. What should we do? Okay, so we're going left 1. So this direction is what? Okay, so that's the 1. So that's going to be, we're going to be subtracting 1 from all the x values. Let's do that. And now what are we doing to y values? We're going down 3. So let's subtract 3. 4 minus 3 is 1. 1 minus 3, negative 2. 2 minus 3, negative 1. I know I'm going fast. 4 minus 3, 1. Now we have taken this figure that we had rotated and we shifted it left 1 and down 3. How are we doing? It's not too bad, right? Could be worse. Let's go back now to slide 14 and see if we can rotate this figure 180 degrees. Looking back at this point here that I have plotted, negative 5, 3, I rotate 180 degrees, and it doesn't matter which way I'm going, clockwise or counterclockwise. This point's going to end up in the exact same place because we're moving 2 quadrants. It's just going, the x and the y-axis are not going to change. So the numbers are going to stay in the same locations. However, the signs are going to change. So, I'm just going to, this figure is moving from quadrant 1 to quadrant 3. What are the signs of x and y in quadrant 3? Both negative. So I'm just going to rewrite this chart here and put it here and just change all the signs to be negative. I feel like you guys are doing really well. Let me know if I'm wrong. Okay. Negative 6, negative 4, 4, negative 6, negative 2, one more, negative 2, negative 2. Boom. Looks good to me. Looking good. Ow! Yes, sir. Last one, slide 13. Am I going too fast? Anyone still writing this down? This is the last one here. Rotate the figure 270 degrees clockwise. So clockwise is going to be 1, 2, 3 quadrants. So it's going to end up in the second quadrant. You could think of it as 270 clockwise, or usually what I do is I think of it the other direction, 90 degrees counterclockwise. It's the same thing. So this purple triangle is going to be rotated in my head 90 degrees counterclockwise, which means The x-axis and the y-axis are going to change locations. So the first thing I'm going to do is switch all the values, the x and y values. I'm going to do that first. Now we are ending up in the second quadrant, which means x is negative and y is positive. The y is already positive, so I just have to change all the x's to be negative, and then we should be good. We'll take a look at it and see what it looks like. Looking good. Any questions? All right.